Welcome to Technical Utkranti, and today we'll be looking into another question on binary search, which involves load balancing. So, first of all, let's have a look at the thought for the day. So, Akka Mahadevi is the famous saint of South India of 12th century AD. All right. So, these are the questions we have done in binary search, and let's have a look at the question. So you are given an array of length m. So there are m numbers in the array given to you, and you have n containers. All right. For example, 1, 2, 2, 3, 1 is the array of length m equal to 5 because there are 5 numbers, and you have n equals to 3 containers. Now you need to distribute these numbers in these 3 containers such that the sum of these container is balanced. So what is meant by balancing is that maximum sum of the container in any distribution should be minimum. For example, here there are two distributions I have shown here. In first one, the maximum sum comes out to be 7, and in the second one, the maximum sum comes out to be 4. So we will accept the answer in which the maximum sum in any distribution is less, is the least. Okay. How are we going to do it? So this intuitively tells us that there should be a cap, a certain cap on the capacity of the container, how much a container can contain, and beyond that capacity, we should not be filling it, something like that, right? So, how are we going to decide that limit? So, one important thing in this is sequential. All right, sequential. So, we have three containers with us, and we can put the numbers in these containers in sequence only. For example, if one comes here, then only two can come here. Or, in other words, if two has to be placed in a container, one should already have been placed in this or the previous container, right? So it cannot be like 3, 2, not this way. It should be sequential. All right. All right. So when will we decide that okay, till here I have filled the numbers and now subsequent numbers will go into the next container. So this we will take help of binary search. We know that in any particular container, the minimum limit that we can put is 0, and the maximum limit that we can put is the sum of numbers. So in this case, the sum of numbers is 9. We'll calculate mid, and it comes out to be, so if this is 0, this is 9, it comes out to be 4. And then we start filling the container with the upper limit of mid value, which is 4. And then we see if it is possible to fill the containers with this capacity. For example, I can have one here, two here, but if I put another two here, it will go beyond 4. So I'll hop on to the next container. Then I'll put 2 here, and if I put 3 also here, then again it will cross the limit. So I'll put 3 here and 1 here. All right. So as you can see that we are able to fill all the numbers in the containers. So the distribution is feasible. If the distribution is feasible, it means that we can try with a lower value also. So in order to make the mid value low, we need to reduce high. And high becomes mid minus 1, which is 3. So low is 0 and mid comes out to be 1. When mid is 1, we see that we can place 1 here 2 cannot come. So if the individual element itself is greater than the mid value, then it is not possible to fill the containers, right? So what we'll do is we say it's not possible to fill with this value of mid. So we need to increase the value of mid. In order to increase the value of mid, we need to make this particular low pointer as equal to mid plus 1, which is 2, 3, and mid comes out to be 2. For value of 2 also, we see that one particular element is greater than mid. So we need to increase the value of mid, and therefore low becomes mid plus 1, which is 3. And mid becomes 3. Again, try to distribute. So 1 plus 2 is 3. 2 comes here, and 3 comes there, and 1 is not able to be put in any container. Therefore, we need to increase the value of mid. And in order to increase the value of mid, we make low equals to high plus 1, which is 4, 3. And as soon as low becomes greater than h, we are done. So we saw that only for this value of mid, we were able to do the distribution, and hence this becomes our maximum capacity. So this becomes the distribution in which the maximum capacity is the least, all right, which was 1, 2, 2, and 3, 1. So as you can see that this particular distribution is balanced also. Like here sum is 4, here sum is 2, here sum is 3. So as you can see that the load is not very high somewhere and very low somewhere, right? All right. Let's have a look at the code. How are we coding it? Low and high pointer are taken as suggested and result is initialized to -1. All right. Now we start our binary search and calculate mid. Now we take one element of the array at a time, which is time is the name of the array. And we see that if any element is greater than the mid value, then we basically say that uh, then we basically go into the condition where we have to increase the value of mid, and hence, so as you can see, I am putting day is equal to n, and when day is equal to n, low is equal to mid plus 1. All right. Otherwise, we see that if the sum plus the given element is greater than mid value, then we know that we have to increase the value of the container now. So here containers are basically the days. So I am incrementing the day value by 1, and assigning the s equal to I, right? So when s plus I is greater than mid, then we basically have s equal to 0 and assign this I value to s basically, right? So we say that for this container we are done, and then we move on to the next container. All right. And if s plus I is less than equal to mid, then we s- put this element into the same container and keep on adding up the sum for that container. Finally, we see that uh, if the distribution is possible. So when it is possible, then we have distributed entire contents and our days are not exhausted. So in that case, distribution is possible. We try with even lower value of mid. All right. And once the distribution is possible, we also allocate the result as mid value. And then we go on until we exhaust all the checks that we have done, right? So how can mid value represent the least maximum value? Because we are directing the mid value in the direction where the solution is coming, as well as if solution is coming, then we reduce the mid value even further. So mid value will go on decreasing only, right? Okay. So let's submit it. As you can see, our solution is acceptable. If you understood the question and the approach and the code, please give it a thumbs up and subscribe to my channel. Thank you. Bye bye.